section is based on function. So we are going to talk about some of the basics of functions. First, a function is a self-contained unit of program code designed to accomplish a particular task. That's a high-level definition. Function is going to be basically something that you can invoke that helps you reduce duplication of code. But what it does is it's a self-contained inside the code itself, and it has just some task that it's going to accomplish. Syntax rules are going to define the structure of a function and how it can be used. So depending on what programming language you see, functions may be defined differently. For C, we are going to talk about specific rules for C. Most programming languages support this concept of a function, and I will tell you the advantages and why they are supported. A function in C is the same as subroutines or procedures in other programming language. So oftentimes you hear these terms subroutines and procedures, same thing as a function. Self-contained unit that executes some code that you can call some functions cause an action to take place. So we are familiar with a couple functions up to displays output to your screen that takes an action, does something for you. And then result, we have also looked at the scanf function, which takes input from the keyboard. Again, it sort of does another action. Other function throw can actually just find a value for a program to use. So for example, when we study strings and characters array, we are going to look at function for string manipulation and changing things. There is a function in particular called string length, and that will tell a programmer how long a certain string is. It doesn't perform an action, it just gives information back to you. So functions are going to perform tasks depending on the task that you need to accomplish in your program. It's either going to cause an action or it's going to modify a program value or return a value or tell you some status information. And the advantages of functions, we are going to use functions because have a ton of advantages. Functions allow for the divide and conquer strategy. So if you were to write down and go and write a medium-sized function program or a large program, it's going to be really hard to maintain. It's going to be hard to test, debug, and find and fix any errors. If you have a single large function, so breaking down and doing this dividing conquer strategy is going to make it a lot easier to find and fix bugs in your code. And can you imagine a single C program that all I had was the main function, and there was 5,000 lines in it? We would have no clue how to attack that problem. It's really poor organizations. You are not having any cohesion and you are just kind of giving right in there to try to solve a problem. So we are going to use functions. Divide and conquer basically means that tasks can be divided into several independent subtasks. It reduces the overall complexity of the code. You can create separate functions for each subtask, and then you can even create more functions to divide the subtask into smaller subtasks. Each time you create these additional functions, it reduces the complexity. Your goal should be when you are creating these functions and using the divide and conquer strategy is to make your functions as cohesive as possible. And what that means is make sure each function is doing just one task. Don't have a function do 5 different tasks or 10 different tasks. If you write a function that reads input from the keyboard, have it read input from the keyboard don't have it check a string or display output or anything like that. Functions need to be small and they need to be very cohesive. But the divide and conquer strategy is really nice because it reduces that complexity. Instead of having a main function with 5,000 lines of code, you can identify them very quickly. So functions are going to reduce the duplication of code. And when you reduce duplication of code, it's going to save your time when writing, testing, and debugging that code. It's also going to reduce the size of the source code. And why do functions reduce duplication of code? Because if you have a task, instead of doing that task over and over and over again, and task into a function, and that just invoked functions, and the function will do it for you each time. You don't have any duplication there. If you have to do a certain task several times in a program, you only need to write an appropriate function once. Just like I mentioned, you don't need to write that code multiple times. So a program can then use that function whenever needed. And you can also use the same function in different programs. And that's what constitutes a library. We have been doing that. We have been using the printf function, which is from the standard input output library. And that's only written once. And we invoke it over and over. If that function didn't exist, we had have to take the implementation of that function and put it in our program and just keep repeating it. So functions can have a lot of time and they can reduce your source code and you can reuse them over and over again. So it's also a software use technique. It also helps with the readability when you modularize your program, which is the what you are doing when you create these separate functions to perform a specific task, the program becomes much better organized. Like I mentioned, if you had a main routine, a main function, and it had tons of code in it, it's going to be much harder to follow than a main routine that calls five functions and those functions do specific tasks. So it helps with program organization, it helps with program maintenance. It's much easier to read and easier to change or fix any source code. And remember, the maintenance phase is the most expensive phase of the software lifecycle. That is where you fixing your bugs. The program has been released and where you are adding new features. The better organized your program is, easier it is going to be to maintain. So this organization, this readability, this being able to follow what's going on in your source code, very important, and functions help a ton. The divide and conquer approach also allows parts of the program to be developed, tested, and debugged independently. When you get out there in the real world and you start working on code, you are going to notice that programs are really, really big. And there's many people working on these programs, hundreds, maybe even thousands low. When you have all these people work on a program, it's much easier to work on that program if you do this divide and conquer approach. If you have small tasks that people do and it's independently, you are not touching the same source code and you can go ahead and implement tasks much easier. And when you do this and you have multiple people working on a project, it can reduce the overall development time, which again reduces maintenance cost, reduces development cost. The function can also be reused, which again will reduce time. And again, we do that with the printf function, reuse that. But you, when you write your own user-defined function, you can reuse them over and over and over in the program. So software reuse is a big advantage of functions. When you are thinking about these functions, the other nice thing about designing your program on functions is you want to think of it as a black box. What it means when you think of it as a black box, all you are thinking about is the output to the function and the output. And when you focus just on the input in the output, it allows you to look at the design as a whole before you start implementing. And so functions in general will get you in this type of thinking where you can focus on design. And I mentioned design is important. Design is when you start planning out your program, how you are going to organize it, how you are going to write the code. And it's important to do this planning before you even start implementation, which is writing the code. And by thinking about functions and thinking about just inputs and outputs, you can think about how the program is going to be organized and what functions you need to create. So you don't have to worry about just implementation in the details. And this is important because the first thing you need to be before writing code is just to think about design. You don't want to start thinking about implementing a lot of skills that students have when they write code. For the first time is the just start implementation, then don't even think about the program. They don't think how they are going to solve the problem. They just start writing code. Never a good approach. When you are thinking about writing code and functions, think about it as just input and outputs of the function, and it's going to help you with your design. So it looks at some examples. We have used built-in functions such as printf and scanf. As I mentioned, those are in the standard input-output library provided by the C programming language. So we are familiar somewhat with what a function is because we have used it, but we have not gone through the fine grain details of how you define a function or how you actually pass data to a function, nothing like that. But with the printf function, you should have noticed that it does take data. You can pass data to the function. The data is the arguments between the parentheses following the function name. We are going to have a whole other lecture on arguments and parameters to explain them more, but a high level understand that you can pass data to a function and understand that by looking at the printf function. The first argument to the printf function, which is the data that we are passing to it, was a string literal. It was all those characters inside of double quotes. And then we also had arguments which there could have been zero or many. There were variable arguments which were a series of variables or expressions whose values were to be displayed. So remember, if we had any format specified in the first argument, we would then have the variables in this in the subsequent arguments. So were you able to pass data to the printf function? You also should have noticed how you can receive information back from a function. Data can be returned to you. In the scanf function, one of the arguments was how you were going to store the data, and so you would pass it a variable, and that variable would have a value whatever the user typed in the keyboard. So that can kind of thought of as a return value in a function. So functions are very valuable because they can take data into them and then they can return data out of them. So a coding example of a function, and this would just be a function that we are going to invoke, but this is the main function. We are familiar with the main function, the entry point of the program. But look at how nice this is. We are calling functions read, list, sort, and average. We only have 3 lines of code. We have to go and implement those functions, but it makes the program more organized because we immediately know what this program is doing. This program is going to read a list. It's then going to sort a list. It's then going to display the average of the list. And the list contains float. So it's very readable. It's going to be very easy to maintain. If we have any bugs in the program, we will immediately know how to find or isolate that bug. If the bug is not sorting, we can go to the sort function. If the bug is in the averaging, we can go to the average function. Very easy to isolate errors. So when we implemented those functions in the previous slide, we were just calling them. To actually implement function, you have to write the code. Inside the body of the function, you can either utilize functions that are implemented by the C language, like printf, or you can create your own user-defined function. You do not have to implement the printf function or any of the functions in the library. You only implement your own functions. So in this previous example with the read, list, sort, and average, we would have to go and we would have to implement that function. We would have to provide a function header, a function body that actually does the reading of the list, the sorting of the list, and averaging of the list. We are not done just by defining function, we have to implement them. And when you implement the function, you always want to use descriptive functions names to make it clear what the program does and how it is organized. In the previous example, we had a function named read list, pretty clear what that's doing. Function name sort, we don't name the function x, y, or z. We described that function. It's the same thing when you are describing or creating variables, meaningful names. And also, if you make these functions where they are generic enough, where they are actually doing something and they are taking generic data, you would actually be able to reuse them in other programs, just like a library function. Again, supporting software use. So in this upcoming lectures, we are going to talk about how we can define a function, the specific syntax, and how we can invoke and call a function, and how we can pass and return data from them. That's what we are going to focus in the upcoming lectures. I also wanted to mention that our main routine that we have seeing over and over in the every C program, that's a function. The main function is a specially organized name in the C system. It indicates where the program is to begin execution. All C programs always have a main. The main function can take data when you pass to it the command line arguments, or it does not have to take data. It also has optional data that it can return. You will notice that we use main function that return 0. Usually that's used when you want to return error codes, but we have used specific functions already, and the most important function is that main function. And that again help organize the code. We always know where the program is starting because we just have to find the main. Hello, I want to talk about defining functions in C. Defining a function, we know the importance of function. We understand the advantages. We will want to use functions in our program. So when you create function in C, you have to specify the function header as the first line of the definition of the function. We are going to talk about defining a function, and we are also going to talk about implementing a function. Implementing a function is just problem solving. It's just regular C code. Defining a function is saying that the function exists. So when you define a function, the first thing you do is you have that function header, and then you follow that with a curly brace that starts the block code for the function. So it's just like when you use a curly brace in an if statement, just like when you use a curly brace in a for loop, except the curly brace is required for function. There is no eliminating it, and it always signifies the start of the code for that function. Anything in between the starting and ending curly brace is the code for the function. It's where you are going to implement the task. So in between the braces is called the function body, and the first line of the function is called the function header. The function header defines the name of the function, the parameter of the function. We are going to talk about parameters and arguments in detail, but right now you just need to know that there's something called parameter, and the parameter is going to specify the number and the types of the values, how you can pass data, specify the number and the types of the values, how you can pass data. Parameter have to do with passing data, the type for the value that the function returns. We mention that function we can return data. So in that function header, you are going to have the name of the function, the data that you can take can be accepted by the function, and the data that's returned by the function. We are not going to focus right now on the data that can be passed or the data returned. We are just going to talk about creating a simple code function. The function body contains just regular code, and that code gets executed when you call or invoke the function. And the function body itself will have access to any values that are passed as argument. So the data that you pass to it, you can utilize that data inside the body of the function. What it looks like is this, a function header. Function header has the first word, and the function header is a keyword representing the type of data that's going to be returned from the function. The next keyword, there is the name of the function, and then you have a left parenthesis, and then you have parameters separated by commas. That will be the data that's passed to the function. And then you have that right parenthesis to end the function header. Then you have the curly brace that signifies the start of the function implementation. And you have any number of statements to do a task. Like I said, you want to have your functions be small. They want to be cohesive. They don't want to be all over the place. They want to have a function that gets input, it reads input, it doesn't print out output. It does not do any sorting or it does not do anything else. If you have a function named sort, it sorts the data. It does not get input. Functions need to be cohesive and small. It's much easier to debug those functions. So make them cohesive. And then you have that right curly brace which ends the function implementation. That is what a function look like in C. Now let's focus on the function names, and we'll talk about the parameters and return types later. The first line of the function, again definition, tells the compiler in order from left to right three things about the function as I mentioned. The type of the value returns the name of the function, and then any data it takes. This is just to summarize that's important. As far as function names, you want to choose meaningful function names. It's just as important as choosing meaningful variable names. It greatly affects the program's readability. So do not name functions X or Y. Name the function based on what it's going to do. If it's adding two number, name it add. If it's subtracting two number, name it subtract. In that example, here our simple function, don't worry about the void, just worry about the name here. We have a function named print message, and then we see that curly brace which signify the starting of the function, and then we have some implementation, and this implementation is doing nothing more than displaying a string or text, and then we have that right curly brace. This is very simple function, it doesn't do much. It displays output. In this example, for the print message, the first line of the print message tells the compiler that the function returns no value. That's the keyword void. Again, don't need to focus on that, but that's what that's doing. The next is the name, and then after the name is arguments. They are called parameters, and we use the keyword void again. If we are not passing any data, the statement in the function body can be absent, but the braces must always be present. So you don't have to actually have any implementation, but you have to have the braces for a function to be there. If there are no statements in the body of a function, the return type has to be void. And again, we will focus on this later, and the function will not do anything because you have no implementation. If you define a function with an empty body, it can still be useful even though it's not accomplishing anything. You usually do that during the testing phase of a very large program. And what this allows you to do is you can run the program with only certain functions. Actually, doing something helps you test better, helps you isolate errors. You could even have implementation in the test in the function body, but just comment it out. And then you can do this divide and conquer approach, and you test more and more and more. You can then start putting implementation in the function bodies. It's a step-by-step process of working. You are constantly working in small chunks, adding code, testing that code, and then moving on to the next step. And then eventually the whole implementation will be completed, and all functions will be implemented. So there is a use case for having a function body that has no code or commented out naming functions. The name of a function can be any legal name, just like when you are naming a variable, you cannot use reserved words. So these are keywords in the language such as enter doubles because they represent data types. Size is operator. You want to be able to use it for, or if you could also not have two functions with the same name, and this is also referred to as function overloading kind of. But you can't have two functions with the same name. Overloading is not supported in C. Lastly, you can have the same name as a function that's in the standard library function. Technically, if you don't include that library, include header file, you might be able to have it. But if you ever wanted to actually use that library function, the compiler would complain and say you have two functions with the same name. So don't name your function the same as the standard library function. A legal name is the same as a variable, a sequence of letters and digits to start off. The first character has to be a letter, and the letter can be an underscore. You can't start off functions with numbers or any kind of weird characters. The name that you choose should be meaningful and relevant to what the function does. I said this already, I am repeating it for emphasize. Meaningful names are very important. You will often define function names and variables names to that consist of more than one word. So now I want to talk a little bit about just coding style. You have probably noticed when I am writing in my code that I use camel case. There are three different ways you can write the names of your variables and functions. You can separate each of the words in a function with an underlined character. It's one approach. You can capitalize the first letter of each word, or you can capitalize words after the first word, and you still have string together. Remember, you can't have spaces in between. This is just an approach for naming because it's important that you follow some convention so that it's easier to read. Just having a long word with five different words. So if you had a function that is says check for valid input, you would not want to have those all lowercase. It would be really hard to read and identify where the words were. Cancel camel case is a way to identify where the words are in. Many words, and that's easy to see what that function is doing. And underscore is another way to separate words, and capitalizing the first letter of each word is another way to separate. It's important to be able to separate the words in a function to make it more readable. I usually use camel case, and when you use one of these conventions, you want to use it for everything. You want to use it for naming variables. You want to use it for your function names. Usually, you just follow this common coding convention. It makes things more readable. Function prototypes. We talked about defining a function. What about declaring a function? We may say, why do you need to declare a function? Are not you declaring it when you define it? But there is also a concept of declaring a function, and it's necessary if you want to use a function before it's implemented, before it's defined. So a function prototype is a statement that defines a function. It tells the compiler essentially all the details of the function. It defines its name, return type, and the type of each of its parameter. So it looks like a function header. It provides all the external specifications of the function. Mainly, you have also probably heard the term signature function. Signature, that what it is, it's specifying the data returned, the data that it takes, and everything about the function itself. You want to write a function prototype the same way as you write the function header. The only difference is that you put a semicolon at the end, and this is just declaring the function. This is saying the function exists. A function prototype enables the compiler to generate the appropriate instruction at each point where you call the function. It also checks that you are using the function correctly in each you know, invocation. The reason that you provide function header is so that you can invoke the function without a warning or a function declaration without it being implemented. So it's just really just the order of your code, and I will give you an example of this in a second. When you include a standard header file in a program, the header file adds the function prototype. Function prototype usually go in header files. If you want to reuse them in many different source files, if you are only using them in a single source file, you can just put them at the top and the source file. But because we are using the printf function, which can be used in many different source files, that header function will be defined in the header, or that function declaration will be defined in the header. And in this case, stdio.h. So they usually appear in source files if only that source file is using that function. Otherwise, you put them in a header file if they are being reused by many source files. It allows any of the functions in the file to call any of those functions that are defined regardless of where you have placed the implementation. If you place the implementation of a function after you call it, she is going to complain and say that does not know about it. Because when you compile, you are compiling line by line. If you place the declaration at the top, then you can invoke the function before it's defined, before it's implemented. Parameters names do not have to be the same used in the function definition. You can have different names. When I say names, those are the identifiers of the data. You can change the name of the parameters in the function prototype. You still have the same data types, but you can change the names. It's always good practice to include function declaration for all the functions in your program at the top of the file. It keeps your program more consistent to the design, and it prevents any errors occurring at any stage if you ever want to call that function before implementing it. Here's an example of some function prototype. At the very top of the file, we have our includes, and then we have some functions that we have declared: average, sum, and get data. You notice it looks like just like a function header. It has the return type as the parameter that are defined in the function, but it has a semicolon at the end. There is no implementation for these functions. You are just telling the compiler this is the function exists and this is how it's defined. What this allows you to do is, now in your main function, you could call the average, you could call the sum, you could call to get data. And the actual implementation can be below where you are calling them. If you don't have the function headers here when you tried to call them in the main. If they were defined below the main routine, you would have errors or warnings. So let's take a look at that in code blocks. Here we have our usual main routine. Now let's say that we want to create a function or we want to invoke a function. We are going to invoke a function called add, and it's not going to take any parameter. We are calling it in our main function on line 7. We are going to implement it on line 10. We are going to say void add, and we are not even going to do anything. We are just going to keep it empty. When we go to compile this, what you are going to do notice is this compiler just gives a warning. It says add as an implicit declaration. You can get rid of that warning by using a function declaration. You can declare the function up top, basically telling the compiler that you are going to use it somewhere, but you don't know where the implementation is. So what you can do is you can say void add right up here and just add the semicolon. Now it will get rid of that warning, and some compile will actually give you an error. Now, when I want compile it, I have no warnings and no errors. That's what a function declaration does. It allows you to put the function anywhere. Now, if you didn't have the function declaration at the top, you had the implementation error where you were calling it, then you also will not see the error because the compiler is going to know about the function before it actually tries to invoke it. So if you build this, you are also going to see that there is no error. Now I mentioned that you usually want to declare all your functions at the top just for good practices, and I think you do need to do that. Keep doing that. But if you do get out of that habit, you either have to declare your function before you call them, or you have to provide function prototypes because you do not want warnings or errors in your program. This is how you can define a function, and this is how you can use function prototypes. Hello, I want to talk about arguments and parameters. These terms tend to be used interchangeably. What they have to deal with is basically data that you pass to a function. So a parameter is a variable, and a function declaration and a function definition implementation. Remember this difference between function declaration, function prototype, and function definition. Function declaration is just the method signature. It's the function header. Function definition is the implementation of the function, the actual code. In both of these terms, declaration, definition, understand those differences, but the parameter is what's in the function declaration and definition, it's in that header. Because both the header is included in the definition in the declaration, when a function is called, the arguments are the data you pass to the function parameter. Those are the actual value of a variable that gets passed to the function. So function parameter defined within the function header, and their placeholder for the arguments function header, and their placeholder for the arguments that need to be specified when the function is invoked. So understand the difference here between arguments and parameters. Parameters have to do with the function definition and declaration. Arguments are where you call the function when you invoke the function, the data that you are passing. So arguments are used when you invoke. You will say these are the arguments that are going to my function. And when the function receives that data, they are referred to as those are the parameters. The parameters for a function are a list of parameters, names with their data types. Each parameter is separated by a comma. The entire list of parameters is enclosed in parentheses following the names of the function. A function can have no parameters, which means there is no data passed to it. And in this case, you just have the left and right parentheses with a void in between them or empty. You can still have it as empty, nothing in between them, but it's a good practice to put a void in between them. Void is a special keyword that means nothing, means no parameters or no return data. Parameters provide the means to pass data to a function. Parameters provide the means to pass data to a function. Data passed from the calling function to the function that is called the invoke to the receiving end, the calling end and the receiving end. The names of the parameters are local to the function. We are going to talk about that when we talk about local data. But those parameters names only exist inside the function body. They will assume the values of the argument that are passed to it. So if you have a function called add, you pass in a variable as an argument. You pass in the value 5 and you have a function with a parameter x. X is going to be equal to 5 anywhere in the function body. The body of the function should use these parameters in its implementation. If it does not, then they should not have been passed. If you have a parameter variable defined in your function declaration definition and you never use that variable inside the function, that's wasteful. Don't include it because that's just saying you don't need it. Don't send data to a function that's not using it. A function body may have additional locally defined variables that are needed by the function implementation. You may have inside the function body other variables declared because they are needed for whatever task you are completing. You don't just only operate on data that's passed to it, you can operate on local data inside the function. When passing an array as an argument to a function, you must also pass an additional argument, have another parameter defined, specifying the size of the array. The reason for this is that the function has no way of knowing how many elements are in the array. So even if you declared an array of size 50, you may only be storing 30 elements. And if you are going to use that array inside the function body, you are probably going to need to know how big it, because you are going to need either iterate through it using a loop or you are going to need to access elements. And if you access elements are iterating through it, you need to know whether or not when you are out of bounds. And we have talked about the out of bounds there and why that's important. Well, here is an example. When the printf function is called, you always supply one or more values as arguments. The first value is that string inside double quotes. The remaining values are any variables to be displayed. This is actually a function that takes a variable number or arguments, which we are probably not going to talk about since this is beginning class. That's more of an advanced concept, but the printf function is a good example as far as passing data to it, because you are passing multiple sets of data to it, either the strings inside the quotes or variables that you want to display. This is why it's so important to be able to pass data to a function. It greatly enhances the usefulness and the flexibility of a function. If functions did not have the capability to accept data, they would not be as useful. In the example that I provided in the last lecture, where we had a function that displayed output, it didn't really do much. It was very static. It did the same thing every time you invoked it, but what if you had a function that took data, then you can control what's displayed. So just like the printf function, if the printf function didn't have parameter, you would not be able to tell it what to display. If you didn't accept data, you would not be able to say hey, display this variables or display this string. It would not be very useful. So you want to be able to pass data to a function makes it much more useful and flexible, and you will see that. I mean, if we do multiplication function, you would not want to multiply the same two numbers every time. You would take parameters and data would be passed to it for two numbers. So you could do different calculations based on the data that's passed to it. Very, very important to understand data passing and why it's very useful. It's good idea also to add comments before each of your own function definition. It helps explain what the function is going to do and how the arguments are to be used. You will typically see this. You will see this in my examples. You have the function declaration at the top of the file. You have the function definition. Function definition includes the function header right above the function header. You have the comments, usually multi-line comments. So you have the slash asterisk, and there you say the same name of the function, the purpose of the function, and then also describe any data that's being passed to the function. This again is for main maintenance and be able to find and fix errors much quicker. Usually you want to have a good name for the function that will tell you something, but with additional comments, it will tell you even more. Here is an example that is a function that multiplies two numbers that gets that getting data passed to it. We have our multiplied two numbers. We know it's a function because it has the parameters essentially. It has the parenthesis. That's one way you can identify functions. When you see parenthesis, I mean, we could also identify because it has a return type. There's multiple things that tell us it's a function. But the main thing is the parenthesis, and then also you see the brackets, the curly brackets that signify the starting and the ending of the block. This multiplied two numbers function through. Remember that the function parameters are defined in between the parentheses and then they are separated by comma. Here we have two parameters. We have a parameters named x and a parameter named y. For each parameter, you have to identify the data type that's coming in. So here we have two ints. This is the standard way to pass data and how to do it in between the parentheses. Data type, then a name for the variable. The name for the variable because anything that's valid in C for the name of the variable, you could call that X, Y, Z, whatever you want. You just can't start it with a dollar sign symbol and then you separate those by commas because accustomed to this convention, parameters inside parentheses. If you had no parameter, no data that's passed to the function, what you would see in between those parentheses is void, or you would see nothing in between the parentheses. This function, all it's going to do is it's going to take the data, that's multiply them together and store them in a variable named results. Or in this case, it looks like I misspelled it. And then what it does is it prints data. It prints out the data that is multiplied. But again, see the flexibility and usefulness of the function. Because it takes data, it can display different data based on what you pass it. When we invoke the function in the main routine here, we say multiply two numbers and we pass in the arguments. We pass in the value 10 or 20. You would pass in variable names here as well, but in this example, we are just saying 10 and 20. This is going to call the function multiply two numbers and it's going to pass in data 10 for the first parameter, 20 for the first second. So x is going to be equal to 10, y is going to be equal to 20. So when we do our multiplication x times y, it's going to be 10 times 20. The result is going to store 200 and then it's going to display the result along with the variables that are being passed to x, y, and z. So it's going to display 10, 20, and then 200. Also notice that we can now use this function. We are calling it again with the different data values 20 and 30 in our second line here in the main function. And then we call it again a third time to multiply 50 by 2. And then we call it again the third time. Okay, we very useful to be able to do this, to create a function that takes different data, make it reusable, make it flexible. And the syntax is very easy to follow. It's just two variables inside of the parentheses separated by commas. And then to call it's even easier, you just space a name. You have the two data, whatever data is separated by common side parenthesis and then ending with a semicolon. You can pass any kind of data type into a function. You can pass an arrays. We are also going to talk about how you can pass in other data types. We have simple examples here, but you can also pass in pointers, which we have not talked about yet. You can pass in structures. Again, another concept we have not talked about, but it's become really, really meaningful and useful when you pass. Talk about returning data from functions. Up till this point, we have know what a function is. We know why it is useful. We know how to define functions. We know how to pass data to function. Now we want to talk about how we can return data from function, which is also very useful. In our prior example, when we multiply two numbers, a multiply function displayed the results of the calculation at the terminal. Remember, we had that printf statement in there. Also, we had an example where we were just a simple function. Earlier, we just printed out data inside the function. We wanted to be nice instead of bring it out there because it's actually doing more than one thing. It actually printed out the data was returned and it printed out the data in the main function. You might not always want to have the results, your calculations displayed. The function becomes more flexible, more generic, which in turn allows it to be used more if you can return data. So functions can return data using specific syntax in C. We should be familiar with this a little bit because remember, our main function at the very end, we are returning data quite a bit in a lot of the examples. So we have been exposed to this a bit. We just have not really understood what it means. Let's take another look at the general form of a function. Remember this function header. We had a return type, which was the word that was first defined. And then we had the name, and then we had the parameters separated by commas inside parentheses. We already know the name and the parameters. The first thing is the return type. The return type specifies the data type of the value returned by the function. Functions can return any kind of data. You just have to let the compiler know what kind of data you are returning. It's an int, a float, a double, whatever it is, you have to specify that in your function header. The return type, we show right here, and you can specify that type of value to be returned by a function as long as it's a legal type in C. I mentioned the main ones, double, float, and so forth, but you can also return enumerations and pointers. We have not discussed pointer, but it makes it very, very flexible when you can return pointers. The return type can also be avoid type. You often see this keyword void. We now understand what it makes. Void means that no data is going to be returned. If you see void before the name of the function, you are not returning any data. If you see void inside the parameters list, you are not passing any data. Void is just a general keyword that for return types and for parameters. You also notice you can use void as a pointer as well, but we will get to that when we get to that. But void is a way of saying nothing. And the reason you include void as opposed to just not including anything, because it makes the program more readable. Actually, when you pass data to a function and you have no data that's being passed, you can have it just be empty parenthesis. It's easy to read if you have void in there. Same with the return type, except the return type you have to have void. You can't have it just be empty. Void means no data is going to be returned. The return statement, we have talked about how you can identify what data is going to be returned, but how do you actually return the data inside the body of the function? You have to have a statement where you can say what you are going to return. Because remember, the body of a function can have a lot of data. It can have local variables. It can have anything. You know, the function could be doing a specific calculation, maybe doing multiple calculation. What do you want to return? Luckily, there's this statement with the keyword return. If you provide the return with no variable name after or expression, that means you are just exiting the function. It's similar to a break in a loop. You are just returning from the function, and you can provide this in function that are defined as void. It makes it clear when you are exiting the function. You should really only have the return in one spot at the bottom of the function. We'll get to that later, but you can't have it anywhere in the function. If you see it anywhere in a function, it means you are jumping out of that function. The reason why it's good to have it at the bottom is it's very clear when you are exiting the function. If you have multiple returns, even if you are returning data all throughout your function, it's hard to say when you are returning. What I like to do in my function is create variables and only return once at the bottom. If I need to return something in a function, or I mean in a specific if statement in a function or something, I will set the variable and the return it at the bottom. So if you have written and you have nothing after it, that just means you are exiting the function with no data returned. This is really not used as much. You only use it in the void function, does not return a value. The more general form of the return statement is returning some variable or some expression, x plus y, or returning x. This form of the return statement has to be used with the return type that's specified in the function header. If you are returning an int, whatever that variable or expression you are returning has to be an int. It has to be evaluated to an int if there you are returning an int. Now, if you are returning a double, it has to value to double. Remember, you can have many different types of data returned. The value that is returned to the calling program is the value that results when the expression is evaluated to. So, if you have x plus y, it's returning the result of that expression, and it has to be the same type as the function declaration as I mentioned. A function that has statements in the function body but does not return a value must have the return type as well. Have to. You cannot have that. If you do not have that, you are not returning any data. You are going to get an error message. When you compile the program and it contains a function with a void return type that tries to return a value, compile error. Void means no return data. Don't return a variable in expression. If a function does not have a void return type and it has a valid return type, you are going to get an error message if the compiler tries to return a different type than is specified, or if they just have returned by with another nothing after it. So pay attention to this. Those keywords in the beginning of the function null declaration are important. It directly affect the implementation of the function, and the compile is going to tell you if you screw up and you don't return the right data, or if you don't return any data, or if you do return data when you are not supposed to return data. If the expression results in a value that's different type than the return type in the function header, C will try to convert it. The compiler will try to convert it if it can. So, for example, if you are returning a float and your expression is I plus X with two ints, it's going to just convert it to a float. If you are returning an int and you have an expression that's doing float calculation, it will convert it to an int. You are going to lose data in that case, but it will do conversion. It's not always possible to do the conversion. In class, in cases where it is not possible, you are going to have an error that's produced by the compiler. If you are trying to return an int when you are supposed to return a string, or when you are trying to return it into when you are supposed to return an enum, it's going to complain the compiler. You can also have more than one return statements function. I mentioned this briefly and why you don't want to do it, but you can do it. You can have multiple returns throughout the function. It just makes the code harder to follow because you are jumping out of the function all over the place. When you do return and you do have multiple returning something, you have an expression or value of that type, or it can be converted. Now that we have talked about passing data and returning data, we know how to invoke a function, but I want to say a couple of other things about invocation. You call a function by just using the function name followed by the arguments that you pass that are in between the parentheses. We know that far we know, but I want to formally state it. That's how you can invoke a function. When you call the function, the values of the arguments that you specify in between the parentheses are going to be assigned to parameters inside the function. The parameters are representative variables with a data type. You can then use that variable any side in the function body. When the function exits or executes a certain code, it will use those values supplied as arguments. As I mentioned, the arguments you specify when you call a function should agree in type, number, and sequence. When the parameters in the function header, order also matters. I didn't emphasize that, but if it says int x double y, you first have to pass in the int, then the double. You can't pass in the double and the int. The order is very specific. So make sure you pass the data as an argument when you invoke the function. The same way as the function is declared in the function header, in the parameter list, passing the right type is that as well. Invoking a function and assigning the data returned. If a function is returning data, the function can assign that data just by using the equals operator, and after the return as well, you can store it in a local variable if you want. It will also work with an expression. So you can say return x plus y. You can say return x. You can say return a constant. This example here is after you invoke the call when you want to assign the data that's returned. So you can say int x equals my function call. Whatever that function returns is going to be assigned to x. And if my function call return x plus y, the result of x plus y is going to be assigned to x. So you can assign the data that's returned from a function call by just having a variable on the left hand side of the call equals, and the function invocation on the right hand side of the equals. The calling function does not have to recognize or process the value returned from a called function. You don't need to have that assignment there. If a function is returning data and you don't care about that data, you don't have to the equals at all, you can just invoke the function. It would not really make sense because if it is returning data, it means that you probably need to look at it, but you don't have to do it. The compiler is not going to complain if you just invoke a function and don't handle the data. It's up to you how you want to use the data that's returned from function calls. Here's an example of invoking a function and also returning data from a function. In this example, multiply two numbers. This was just like the example we had previously, but the previous example didn't return any data. The previous example displayed output. In this example, we are not displaying any output. We are returning the data and then we are displaying the output in the main function. Here our multiply two numbers takes two integers as parameters. We multiply those two integers and then instead of printing this amount or the value, we are using the return keyword and we are then specifying a variable named result and then we have the semicolon to end it. When you see what return keyword inside the function body, you are returning that data. And remember, you can have that multiple places, but you only have it return one value. You cannot return multiple values. So if you have the return keyword in multiple places, it has to be inside an if statement or loop because you are jumping out right then. If you have a return followed by another return, it will give you an error because it would say you have two returns in both cases. You are always returning to results. You can't do that, but the return keywords important. You are returning a variable and then you see in the main function the data that's being returned is being assigned to another local variable called result. You will notice we are using the same names here. This has to do with the function scope, which we are going to talk about in the next lecture. Local variables versus global variables. All you need to pay attention in this lecture is the fact and this function multiply to number is returning data. How you return it? You return it using the return keyword followed by the variable of the expression. You also notice that the multiply two numbers specify the return type at the top of the function header. It returning an int, so we have to return an int. You also notice that when we assign the data in the main function, we are assigning it to int. Assigning those very easy. We just have the equals operator. If we didn't care about the data, we could just call multiply two numbers and then do nothing with it. But after we get the data, return it from the function, we then print it out using a printf function. This makes the function more cohesive that it takes data. We are not actually displaying the results inside the function. There are times when we don't want to display the result, we just want to multiply. Hello, I want to talk about local and global variables, very important topic regarding function. This is really the concept of function scope or in general program scope. It has to do with when you can use variables and when you cannot use them. We know what functions are. So now I want to talk about local variables. Local variables have to do with anything that has a block of code. So variables defined inside of a function are known as automatic local variables. So in that function body, in between those starting and ending brackets, if you declare a variable, that variable is a local variable. It will automatically be created each time the function is called. Also, any values in the access to that variable is only local to the function. You can't access that variable outside of the function. So the variable cannot be accessed in other functions if it's local to a specific function. It's only accessible from where it's defined. If an initial value is given to a variable inside of a function, that initial value is assigned to the variable each time the function is called. If you want to retain a value in a variable every subsequent call, there is actually a way you can do that in C. It's called referred to as a static variable inside of a function. That's again more of an advanced concept, not in beginner class, but it's a way that you can actually have different data every time you invoke function. So if you wanted to, for example, keep a counter of how many times a function was called, you would declare a local variable inside that function named static with a static keyword. But without just regular local variables are going to have new values each time, you can use the auto keyword before the data type, but it's not necessary. It does make it a little bit more precise. The compiler is going to add it by default if you don't include it. But if you do include it, it's just going to make it more precise. It's not necessary. So it's called an automatic local variable. There is a keyword named auto in C, but you don't need to provide it provided by default, and that's why you don't see it in a lot of examples where variables are being defined and declared inside of a function. Local variables are also applicable to any code where the variable is created in a block, loops, or if statement. Again, if you have an if statement in what's block for an if statement, it's just where the brackets start. That's referred to as block. Block can be in functions, blocks can be if statement, blocks can be in loops, blocks can be anywhere that there's brackets essentially. Anywhere there is brackets and you create that variable. Creation of the variable is declaring it and maybe assigning value to it. But if you declare that variable, you create that variable inside of a block. You can only use that variable inside the block. If you try to access that variable outside the block, it's not going to be used. So if you have an if statement, inside the if statement, you declare a variable, you can access that variable outside of the if statement block, same with loops. It's very important to understand this. The compiler is going to complain and give you an error if you try to access it somewhere else. And that this means is the values in the data is only applicable to that block. You are not sharing any data. Global variables is the opposite of a local variable. Global variables can be accessed by any function in the program. The way that you create a global variable is you just put it at the top outside by any function. Global variables are declared outside of the function and they do not belong to any function. Remember the main keyword, the main is the function. So any variables defined in the main function are only accessible in the main function. So the variables in the main function are not accessible in any other function. If you want a variable that used by all function, you put the variable outside of a function, usually at the top of the resource file, and usually mark it as saying this is a global variable. The global variable is a live for the entity of the program from when the program starts to when it stops. What global variable is going to be located in memory. Any function in the program can change the value of that global variable because they have access to it. They can modify it, and so you should now you have code that can access the same data anywhere, but we will get to that. If there is a local variable declared in a function with the same name as a global variable, then that function will use the local variable. It will mask the global variable. So if you have a global variable named x and you have a local variable named y, named x inside of function, the local variable is going to take precedence. It's not going to modify the global variables data. If you assign to that variable, it's only going to modify the local variable. So the global variable is not accessible when you have the same name, and it will actually not be accessed within that local function. So don't use the same names basically, because it's just going to be confusing for people that have programmed a lot advanced programs. They are immediately noticed this. They will say, hey, this just acts, it's just modifying local variables, even if they see a global variable with the same name. But for beginners, it's not always very clear. Let me give you an example. Here in this example, we are creating a global variable at the very top before the main function. And the way you want to organize your program usually have you include statements at the top after some comments maybe, and then you may have some defined constant, and then you would have your global variables. Global variables look just like normal variables. It's just where they are actually declared. If they are declared outside of a function, then they are global. So in this example, we have a global variable called my global. We are initializing it to 0. We can also initialize these global variables anywhere. We can initialize them when we declare them, or we can initialize them in any function. It's an integer. We also have two functions, the main functions in a function called my function. Inside there we have local variables which are only accessible inside those functions. In the main function we have a my local main. You can only access my local main inside the main function, but because my global is a variable that's global, you can also access that in the main function. So the main can access two variables, the local and the global. And my function is a local variable named x because it's declared inside the brackets of the function body. And we can actually access the global variable, which is my local. We can also access x, but we cannot access my local. My local main, I should say, because my local main is only inside the main function. We don't have access to that. If we try to write or read my local main variable inside the my function, the compiler is going to give you an error. You need to understand the concept of local versus global. Local are inside blocks of code. When they are declared, you can only use them in the block. If a variable is outside of a block and it's just in a function or it's just in the program itself, you can access it in any function. Global variables should be avoided. Global variables are sort of a bad thing. The reason for them, for global variables being bad and why you should avoid them, is because it promotes coupling between functions. What does coupling mean? Coupling means dependencies. If you have a global variable and it's being used by four functions, that means each one of those functions could be dependent on the other function. What's wrong with dependency? Dependency causes a program to be more harder to debug and find errors. If you have a bug in your program and you are using a global variable and the global variable is causing the bug, now that bug could be anywhere in any function that's using that global variable. It complicates thing when you have global data. You have a global variable, it could be modified in the function 1, function 2, function 3, function 4. You are not restricting access to that. It's also very hard. Once you find the error and you isolate it, it might be very hard to fix it, because now when you fix it, you may cause problems in other program functions because of these dependencies. Global variables should be avoided as much as possible because of this coupling, because of these dependencies. These are times when you may need to use it, but you should avoid it. And to keep in mind, most modern languages, in most object-oriented languages like C++ and Java, don't even have the concept of a global variable. They have static variables which can be class variables, but they are still encapsulated inside of a class. Because global variable is such a bad thing, new language actually try to prohibit and you should try to avoid it because it just complicates your program and make it harder to find and debug errors. Instead of using global data, pass data to function. If a function needs access to some data, pass it to it. If it's a lot of data and you don't want to have a lot of parameters, in theory, you should never really have more than 5 parameters. There's a great book out there called Clean Code that talks about the quality of code and things to avoid like global variables. It also talks about how many parameters you should have in your functions. And if a function has 20 parameters, it's an indication that something wrong. Mainly because that function is probably doing too much. But a function can have access to data by just passing the data to it. And you can restrict the use of global data. And for a function that takes a lot of data, you can use something called a struct, which we have not talked about, but that's another way to do that. So don't use global data as much as possible, only when necessary. Make sure you understand the code. Make sure you document it really, really well so that somebody else looking at the code immediately knows that you are using global data and knows how everything works. This is the concept of function scope. You should need to understand this, so pay attention to all these field slides. Of them, there are some more advanced concepts related to functions like functions, pointers, and static and automatic static variables, recursion. But those things are going to be discussed in an advanced class. Now that we know the basics of functions, I want to provide you with the challenge so you get familiar with creating and using functions. So you are going to actually write a number of different functions. We need to start getting some practice writing these different functions. And why do we want to write functions? Because it makes our code more organized, more modular, and you can avoid duplication. We went through all the advantages. So the purpose of this assignment is to get you familiar with functions, understand these advantages. So you are going to write 3 functions, and you can have all these functions defined in a single program. I want you to write a function which finds the greatest common divisor of two non-negative integer values and return the result. So you can create a function name called GDC. A function should take 2 integers as parameters. The algorithm to find the greatest common divisor pretty simple. You can look online or find any math book. What you should be noticing in these challenges is that they are getting more and more difficult. I'm not going to provide you with every single hint. You have to come up with the GDC algorithm. It's very easy though and very common. It's common function. Have this function take data and have it return data. Two non-negative integer values it accept. You can either check for negative integers if you want, or you don't have to. It's up to you. I also want you to write a function to calculate the absolute value of a number. The absolute value of a number is positive value. So if you have a number -5, the absolute value of that is 5. If you have a positive number 5, the absolute value is 5. It's very simple function. Actually, the implementation of this function, all you are going to need to do is really check if it is less than 0. And if it is, just make sure it's positive. If it is variable, you just say x equals -x. You will want to test this function with ints and floats to make sure it works. To make the absolute value function more usable, I would have it to take a parameter as a float and return to float. That way, you can actually use it with an int and you will not lose any precision. If you pass an int in there, it's automatically going to convert it to a float. And if you had an int, have the parameters an int and return it an int, if you try to use a float, you would lose data. So make it take floats. Third function that you are going to write is going to compute the square root of your number. Don't use any helper or any standard library function. Do the square root with an algorithm that you create. I also want you to check the parameter passed to this method. If you have any values passed to the function and the values are negative, I want you to display a message and I want you to return a negative one. What this means is you can actually use the other function you created. Absolute values as a helper function, that's what you use. When one function uses another function, it sometimes is referred to as a helper function. So the square root function, I want you to invoke the absolute value function. You can use that to test whether or not the arguments are negative. You can also actually use it when you do your computation of the square root. Even though you are returning a negative number, you still want to call the absolute value function when you are performing the square root itself. So these are the three functions I want you to write. You are going to be exposed to creating, declaring your functions. I want you to have function prototype at the top of the file because remember that's good convention. I want you to return the correct data. I want you to pass data to these functions. So you are going to have to understand the whole entire function signature. And then you are going to invoke these functions. When you actually go and start testing the program, make sure you have a lot of test cases. Call the GDC function with multiple values. Call it with negative numbers. Call the absolute value function with many different values. You can test all this by just invoking the function in the main function. And then you can also have normal output with this. I will show you my solution. So get a little planning out of way to try to figure out that this is challenge one. Okay, even though I gave you a lot of hints, challenge is going to be more about divide and conquer. It's going to be more about organizing your program around modules. It's going to be more about problem solving. What I want you to do is I want you to write a tic-tac-toe game. This is going to help you just become a better problem solver and it's going to help you organize your program around functions. You are also going to utilize an array. You are going to have to figure out how to format certain data, but it's going to be simulation of a tic-tac-toe game. We are not going to write a computer. It's going to be player one versus player two. So I want you to write a program that plays tic-tac-toe. Hopefully everybody is familiar with this program or this game. I should say it's just a game that's played on a 3x3 grid with the two players. You take turns. Hopefully that rings a bell. I didn't want to have to go and explain the game, but hopefully you are familiar with tic-tac-toe. I'm going to provide a little demonstration of how it works and how I expect the output to play out. But it's a basic tic-tac-toe game. What I want to do is you are going to probably need to create an array to represent the actual board, the 3x3 grid. I think you can get away with just creating a single dimension array. You could actually create a 2D array as well to represent the rows and the columns. 2D array probably more intuitive, but it might be a bit harder to visualize in your code. But either way works. The good thing about programming is there's many solutions to a problem. I'm going to tell you one of my solutions and my design approach, but feel free to change the design as long as you are using the construct correctly. That's all I care about. I want you to learn how to use C. As long as your program modularized and it's organized and it's easy to maintain and it's quality code, that's what I'm worried about. So one way to implement only one way is representing the board as a single dimensional array with an 10 elements. The reason I have 10 elements here is I don't want you to use zero. These 10 elements are going to represent the board, but they are also going to represent the coordinates on the board. So I'm going to demo this and show you how I'm thinking of working. But the way that you are going to actually pick the box that you want to draw in a, is going to be based on the element number. In addition to creating an array for the board, you have to try to think of how you are going to break this problem down, how you are going to organize it. I'm thinking at the very common minimum that you are going to need at least three functions, probably more, but you need at least have one function that checks for winners. This will basically just see if a person has won the game, or they may also even check for a draw. You should have a function that draws the board because you are going to be drawing the board after every player's turn. And you are going to be using this another function for marking the board. This happens when the user actually wants to put X or an O in a certain box. You need a function to set that box as an X or an O. What will happen is you will probably be populating the array with that X or O. And that way you can look at the array to see if you won or lost. And in the mark board, it would also allow you to check for an invalid selection. So if a valid selection were 1 through 9 and the user entered 10, you would say, hey, you can't do that, try again. The game should be user friendly, should be intuitive to use as far as a user perspective, and it should be organized as far as a programming perspective. Really think about this one. Get some planning out, do some planning, get some paper out, start writing some design about how you are going to at- attack this problem and that function you are going to need to use. The way that I am thinking of this is going to run. Let me show you you a little demo. I'm not going to show you any source code, but this is what I envision the game will look like when we run it. Maybe a little title that says, hey, the game, and then also a little information about the player. Player 1 is going to be X, player 2 is going to be O, 0. Remember that this does not have to be playing the computer. You can just put it in its turn. So you had have to play this game with a friend who is sitting next to you, and they would have to tell you where to put the number. If you are getting really ambitious, you can write the game to play against the computer, but you will notice that the 3 by 3 grid has numbers in it initially. You can use these numbers to enter. So if you player one wants to take their turn and they represent X depending on what numbers they enter, that's where the X is going to be placed. So we print the grid, we display the board, and then we also tell the user whose turn it is, and we tell them to enter a number. So in this case, I'm going to go ahead and enter number 2 and hit return. And what will happen after I hit 2 or return? It's going to actually see if somebody won. It's going to clear the screen and it's going to redraw the board. So after I hit 2 and enter, you will notice that I still have the title. I still have player 1 and player 2, but now in box 2, I haven't.